Então vamos à discussão. Nós temos 25 minutos mais ou menos. We have around 25 minutes for discussion. That's good.
Thank you very much for a very interesting talk. I will go for a question that is outside my field of expertise, then excuse me for the silly things maybe I would say. But I sometimes enter some of the literature about the philosophical evaluation of how good is scientific knowledge. And there is, I think, a strong debate between a view of refutation as the good way to build knowledge and another alternative way of fitting data to models and evaluate how the fit is good. And I wonder how this debate that seems to be very acid merge with this evaluation that you have several kinds of ways to achieve knowledge, and that depending on the objectives of your work, you can use one or other of them. So I would like you to say if you thought about these things and what can we imagine about this debate compared to your talk.
Yeah, no, that's a very good question, and you know, it's like part 3 of the talk, and it's a part that I didn't give not just because I wouldn't have had time to do it, but because I'm probably not really ready to do it. I mean, there's a I can give you some sort of broad sort of impressions of what would be in part 3. Is this on? Is it working okay yet? Yeah. So one of the things that would be in part 3 is this whole notion of falsification, this Popperian business, refutations, however you want to describe it, presupposes a kind of deductivism, right? Presupposes a relationship, the sort of deductive relationship that I mentioned earlier, that doesn't work, that isn't there. So it won't work. So it goes out the window, basically, the first step. You know, forget about that. So let's get, then if you're going to get on with the business of sort of positive confirmation or testing or whatever, I think when it comes to statistical models and to generating knowledge based on observation, you know, bottom up stuff, I think probably some kind of a Bayesian account is what I would be inclined to pursue. The evaluation of models is of non-statistical models, right? The evaluation of models that are used maybe to generate empirical expectations or to develop theoretical ideas, I think depends on a couple things, right? If you're using models to generate empirical expectations, then and the expectations that you generate aren't you know, turn out not to be there, you know, then that doesn't say good things about the model. So there's a kind of falsificationism or you know, at work there, that kind of, you know, testing in that sense. But an important part of the evaluation of models, I think, also is has to do with plausibility arguments. They're arguments based on theoretical considerations. They have to do with the structure of the model. You know, are there, you know, and Stephen actually gave lots of good examples of you know, ways in which he used the you know, sort of the foraging and predation predicaments of fish to, you know, to develop rules, behavioral rules for the you know, for the organisms. And so I think I would place a lot of emphasis on these plausibility arguments. You know, that for, you know, when the ones that, you know, the arrow that went up from the theory to the model. So, but a lot of this, you know, again goes back to the fact that you know, the philosophy of science that was developed to deal with theory testing and that whole side of the development of scientific knowledge doesn't apply very well to a science like ecology. And so philosophers of science, in a way, need to get busy developing the tools. I think we sort of dropped the ball on that.
I have one question. Some time ago, and still going on, but I think it lost a little of momentum, there was all this discussion about what ecologists should do, either case studies or look for generalizations. And I think that your talk is saying neither one nor the other. We should move more along a kind of gradient as we get into more applied interests. We should go more into details of causal mechanisms, and if you are more interested in theoretical or generalizations that can account for several different kinds of systems, we just move in that direction. It looks like that discussion was a either-or case, and you are kind of saying it is a gradient. It doesn't make much sense to ask if it is one case or the other.
Yeah, no, I think that's exactly right. Kristen was here last year, right? And Kristen Schrader-Frechette. And I think maybe her views have changed a little bit, but she wrote a book with Earl McCoy, in which she argued essentially that ecology was sort of destined to be a science of case studies. Yeah, I don't think that's true. I mean, I think that the case studies are important, and a lot of the work that you guys are doing here is directed toward understanding concrete systems, and I think that's really important. But I don't think it's the only thing going on, right? So I agree. I mean, I think it's more. I think we should be more pluralistic about this, and a bigger house, a more commodious house. There are different kinds of of inquiry in ecology, and they contribute to this broader, I mean, the overall goal is understanding, and understanding, I would argue, is delivered in two ways: by understanding mechanisms, but also by having perspectives that unify broad ranges of phenomena.
I was talking with Renato, and we didn't understand very well in the beginning of your last answer why you put refutation out of the window so quickly in your answer. And I would like to bring to discussion. I don't know, maybe you probably know. I have written, but I don't understand it quite well. But Deborah Mayo has a huge argument about the ways that refutation could be used in a more proficuous way than Popper thought about it. And she's very critical about changing to another paradigm of building of scientific knowledge that would come from Bayesian way of thinking. So I would like you to explore a little bit more your first part of the answer when you discarded hypothesis testing as a good enterprise or something that I didn't understand very well.
No, so there's a sort of philosophical issue, or reason that I that I probably should have said something about. So Popper was a falsificationist because he didn't believe in confirmation, right? He didn't believe that any kind of inductive logic, would ever work. There's this classic problem, that traces back to David Hume. It's called the problem of induction. And Popper thought the problem of induction was insoluble. And so the only thing that you could do for Popper was propose bold hypotheses and try your best to falsify them. And the question that was always an embarrassing question for him is, well, the fact that a hypothesis has survived a whole series of difficult tests, for Popper can be no reason to believe that it's true, right? That would be induction, right? And that, so he invented other terms for it, and he sort of danced around the issue, but in the end, he couldn't really, he didn't have the resources to account for the way in which testing builds up the credibility of a hypothesis, the way passing tests builds up the credibility of the hypothesis. I mean, I don't challenge the idea of hypothesis testing, of putting hypotheses to the test, and I don't challenge the idea of rejecting them when they fail to pass the test. But I do challenge the idea that this can all be put in a tight deductive structure, because there are always I mean, in my book I talk about something that Carl Hempel recognized late in his career. He calls it the problem of the provisos. There are always things that have to be sort of assumed in the background that could not everything can be made explicit, and so you can't turn scientific inference into the kind of tight deduction that Popper believed that you could. That makes falsification possible. So yeah. So I mean, I'm not rejecting the idea that we put hypotheses to the test in the sense that we get them to generate predictions and we use how they perform as a way to assess their credibility. I just don't think it should be called falsificationism or any sort of Popperian approach. Does that help? Okay.
I'd like to add something to that, because this means, Greg, that we had a big problem with hypothetical deductive logic. Because we need something that will be a hypothetical inductive logic. Am I right? That I can take this from what you just said. And as far as I know, nobody did that. So there is a kind of mismatch between what scientists have been doing using AG logic and what this kind of idea that we can control everything and for the premise who need them to do. And we are not given the AGI method, if this is possible, the AGI logic.
Well, yeah, I mean, so our talk here is getting sort of increasingly sort of inside baseball, but
it is true.
But it's interesting that that the person I mean, the person who gives us the problem of the provisos is Carl Hempel, who is the champion of hypothetico-deductivism, right? And I mean, he's the fellow who developed and proposed HD explanation and HD confirmation and so on and so forth. And he's the guy in the 1980s, late 80s, that said, "Well, I guess it doesn't work."
Are you speaking Portuguese? He? Bem, primeiro eu queria agradecer, o presente que foi dado, a minha formação com essa apresentação. E eu fiquei meio interessado quando você falou sobre causalidade. Eu fico meio em dúvida em quando você pode dizer que um fenômeno causa outro, A gente entende quando existe correlação, a gente pode dizer um fenômeno é muito relacionado com o outro ou não. Mas quando é que a gente pode dizer que essa correlação implica uma causalidade?
Well, first thank you for the compliment, and that's a very good question. Oh, yeah, it's a good question. I talked a little bit about the difference between active and passive counterfactuals, right? So, if we can understand how a counterfactual circumstance arises as a result of an intervention, then the generalization, the gnomic force that generalization has reveals causal mechanisms. So let me back up. I mean, so the general idea, the approach to causation is sometimes called a manipulability approach to causation, right? So we understand causes by, in terms of the way in which we can use them to intervene in the world, right? So, but probably the person who's going to give you a more detailed answer to this, and the person that you should be asking this question of this, is the next speaker, because he's going to be talking about causal mechanisms, and I think our views are pretty similar. I think manipulation would be for me the key to identifying causation. Okay.
I'm curious whether philosophers of science have thought about this.
That's the problem.
The difference in the use of the term general theory between
Desligar o microfone, tá dando interferência.
the difference in the use of the term general theory between the hard sciences like physics and chemistry and the complex sciences like ecology and economics. And do they see that as just a historical artifact or a problem that needs to be solved?
The use of the term general theory?
Yeah, like in ecology. In ecology, people use the term general theory to mean theory outside of. In ecology, people use. People use the term general theory to refer to, thought experiments, things that are pretty much outside of reality or testing against real observations, whereas in the hard sciences, a theory is general because it explains a lot of observations. And so, do philosophers of science think about that discrepancy, and do they see it as just a historical artifact or a problem that needs to be solved and something that philosophers need to think about?
Much better.
Yeah, so that's a good question, and I guess there are a number of different, not surprisingly, a number of different views on this. So I mentioned a person named Nancy Cartwright, and she wrote a book called How the Laws of Physics Lie, and that's not, that's fib, right? Not how they don't tell the truth. And basically in that book, she argues that, that the theoretical models, even the theoretical models like in quantum mechanics, harmonic oscillators or whatever, are themselves works of fiction, and they manage to be explanatory by virtue of that. And so that's one extreme, and there are a lot of people who've responded to her saying no, we these models contain all sorts of idealizations and approximations, but the fundamental laws that they're after are what really do the explaining. We just need to, the manifestation of the laws in real phenomena is sort of messy because there are all sorts of intervening conditions and things, and so we need to idealize and the frictionless plane and all that kind of stuff. But it's still approximate truth. So that's at the level of physics. There's already this sort of controversy. When it comes to ecology, I think there's more of an inclination, or sciences of the complex. There's more of an inclination to. There's one response, and it's Kristen's response, to say, there aren't any laws in ecology. Ecology is just a science of case studies. Then an alternative response is to say, well, you know, there are some sort of general capacities and tendencies in ecology. You know, some things that ecological systems tend to do if they're not, you know, if the circumstances are right, and that we can explore those with theoretical models. They aren't really laws, but they're sort of abstract dispositions. And then there are, you know, people like Alex Rosenberg who basically, you know, I mean, he wrote a book, it was a while ago. The title of the book is called Sociobiology, the Preemption of the Social Sciences. Right? So he basically was going to sort of throw all the social scientists off campus and turn, you know, and just do biology. So, and his views are more radical still. He thinks there's physics and maybe chemistry, and that's kind of where science peters out. So philosophers of science are all over the map. What we really need, though, I think, and work on this is underway. Maybe Stuart will be talking about it. We need a philosophy of modeling. Is what we really need. You know, we need to understand what we're doing in the practice of modeling, and how that connects up with theory testing. And you know, there's a bunch of work to be done. You know. I loved your line the other day about the whistle and the stop. You know, well, I mean, in order to blow the whistle and yell stop, you have to have some authority, right? But to have the authority, you need to earn it. And I think, you know, philosophers of science have a ways to go in ecology to earn it.
Oh, there is
someone back there.
Oh, okay. So for a final question, then move to I think it's
So, well, I hope we can formulate this question. I've been thinking about it since the question session starts a little, but I think it's related to Steve's question. I see that in physics there's very strong dichotomy in the researchers, like the empirical researchers and the what they call sort of like theoretical researcher, and I don't feel that in this field there's so much of a separation between theory and modeling. It's more like theory is modeling, and from what you presented, and I agree with it, it's not the same thing. It's like theoretical background, the theoretical argument, and somehow there's an interplay between theory and modeling, but there's also an interplay between theory and empirical work. In the sense there are a lot of empirical works out there that are not doing modeling and they are talking in some sense to theory. So I'd like a comment on how this interplay differs between theoretical, not theoretical, like modeling and empirical work, how the interplay with theory is different in each case.
Yeah, that's a very, very good question. So I think, you know, what I've been arguing for is a kind of pluralism, right? A kind of methodological or sort of, you know, a pluralism of, you know, that makes room for scientists engaged in different kinds of ecological inquiry. Some more empirical, some more theoretical. I think, you know, if you look at the history of ecology, ecological systems are just hard to understand, and so it's, you know, the discipline, I think, hasn't always had confidence in its sort of achievements, right? In its status as a, you know, as a science. I mean, Howard or Eugene Odom, in a classic work, I think it had the title of something like "Ecology: The Link Between the Natural and the Social Sciences." Well, what natural scientist wants to be linked to the social sciences? I'm just kidding. So I think as a consequence of that, a kind of disciplinary self-consciousness, there's been a bit of an inability to, you know, for groups that are doing ecology one way to see the value of groups that are doing ecology a different way, and I think that that's, you know, that's really unnecessary, because I think that the different contributions, you know, are all valuable in their own way. You know, I'm not denying that, that there are, for example, mathematical ecologists who see ecological systems as the occasion to, engage in sort of mathematical aesthetics or whatever. They're just doing it just to do the math. So I mean, there are problems, but I think that in its search for a way forward, ecologists have sort of maybe attacked each other more than really they need to, because I think that these different ways of doing ecology are all contributing to these broader cognitive goals, and we just need to get on with recognizing those goals and with getting better at assessing when we're successful in practicing ecology in these various ways.
So, thank you, Greg.
Thank you.
Thank you very much, Greg. I know that we'll move to Stuart, and while Stuart sets his computer, I will make his presentation, if you don't mind.